Hello, welcome to video 5F. This is Mr. Miller, and today we're going to talk about where functions are increasing or decreasing. So as we go from left to right in the graph, a function is increasing if it goes up. For instance, here in between x equals -5 and 2, as x gets bigger, y gets bigger also. That's increasing. And decreasing is when x gets bigger and y gets smaller. The function is going down. So at first we're going to identify where this happens using a graph, but then we're going to use the first derivative to tell us where this happens. Okay, so here's our first example. We have a nice cubic function here, and our first instruction is to find critical points and points of discontinuity. Alright, so critical point is where the first derivative is 0. We see we have a critical point right here. And we also have a critical point right there. Those are two places where the tangent line is horizontal, and the first derivative would be 0. So we can say at x equals 0 and x equals 2. And it could also be at a place where the derivative is undefined, but there's no such place in this graph. Okay, now we're supposed to find intervals where the function is increasing or decreasing. So I'm going to put DEC for decreasing. It's decreasing all the way up to x equals 0. The function actually goes to -infinity. And it's decreasing all the way until we get to here. It's kind of like the bottom, the valley. So we can say from -infinity to 0. Then it turns and it increases until we get to x equals 2. So we can say increasing from 0 to 2. And then it turns again at this critical point, and then it's decreasing after that. So we'll put 2 to infinity up here with where the function's decreasing. So one thing I want you to see is that it doesn't have to, but the function can turn at the critical points. It's going decreasing here, turns at that critical point, goes up, turns at that critical point, and goes down. It doesn't have to, but those are places where it can turn. Okay, same instructions here. This function only has one critical point. It's right here. That's a maximum point. And so we can say x equals -3. That's the value right here. Okay, and so it's increasing from -infinity until we get to -3. As we go from left to right, the function's climbing. It's going up and up and up until we get to the peak here. So from -infinity to -3, and then it's decreasing after that. It turns at the critical point, and it starts going down. So from -3 to infinity. One thing I want you to notice is that the first derivative would be positive here. Plus, 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 plus. The first derivative is 0 here at the horizontal tangent. And then the first derivative would be negative on this side because the function is going down. The slope of the tangent line is negative. So critical points where the derivative is 0 is a place where if it is going to change, it will. So the derivative changes from being positive to negative. That critical point is right in the middle there. Okay, let's take a look at this one. This is a little bit more exotic function. Has an asymptote. So it says list the critical points or points of discontinuity. So the critical points would be where the derivative is 0. It occurs at x equals 0 and x equals 2. These are the critical points. There's also a discontinuity. This graph has a vertical asymptote, and it occurs when the denominator is 0. Well, the denominator would be 0 when x equals 1. So that's a discontinuity. And the function can change from increasing to decreasing there. Actually, here it's decreasing on this side, and on the other side it's decreasing there also. Okay, so let's write the intervals. We'll start with increasing. Function's increasing from -infinity until we get to this critical point here. So from -infinity to 0. And then it's decreasing from 0 to the asymptote. So we'll start our decreasing list. from 0 to 1. Between 0 and 1 is going down, approaching that asymptote. Okay, from 1 to 2, it's coming down from up here and approaching that critical point. So it's decreasing from 1 to 2 also. And after 2, it's increasing. So this was a more complicated function. We kind of had 4 different intervals here we're talking about. Okay, one last example with a picture. On this one, we want to find the critical points. Well, this is not a place where the derivative is defined. Actually, the derivative is undefined here. That's a cusp. That kind of sharp corner is a location where f prime doesn't exist. But that is a critical point, right? So we get x equals -2. Remember, a critical point is where a function's derivative is 0 or undefined. The derivative is undefined there. So that's a CP. And even though the derivative is undefined there, it can be a place where the function changes direction. So, okay. So it's decreasing until we get to that critical point. And it's increasing from -2 to infinity. Okay. Now, we want to start using calculus to kind of find these intervals without a picture, kind of. So there are several steps. The first step is to find the critical numbers, to set the derivative equal to 0 and find where it's equal to 0 or undefined. And then we're going to kind of use a number line to help us figure out the intervals where the function's increasing or decreasing. Okay, so here we go. We're going to do step 1. We're going to locate the critical numbers. So we're going to find y prime and set it equal to 0. So y prime, in this case, is 4x plus 4. We're going to set it equal to 0 to find the critical points. So if we add 4 or subtract 4 to both sides, we have 4x equals -4, or x equals -1. That's a place where the function can change from increasing to decreasing. Okay, so we're going to graph that critical point on the number line. And then we're going to test the first derivative. If the first derivative is positive over here, it's increasing. So let's see. If we pick a point over here, for instance, like -2, we're going to test the intervals. We're going to put a point in the interval into the derivative, and it'll tell us whether it's increasing or decreasing. So y prime of 2 would be, of -2 would be 4 times -2 plus 4, which is -4, which is negative. So actually, since the first derivative is negative over here, function's decreasing. So we're going to represent that with an arrow going down. Okay, function's decreasing there. The derivative is equal to 0 at -1. Let's see what the derivative is equal to the right of -1. So let's try y prime of 0. Y prime of 0 would be 4 times 0 plus 4, which is 4, which is positive. So over here, the derivative is increasing. So on this side, the derivative was negative, so the function was decreasing. The derivative is 0 here at -1. And then for over here to the right of -1, the derivative is positive, which means the function is increasing. So we can now write our results. It's decreasing from -infinity to -1, and it's increasing from -1 to infinity. Now, if it's decreasing until we get to -1 and increasing after -1, that means x equals -1 is a relative max. I'm sorry, min. I don't know what I was thinking there. It's minimum. It's decreasing. It turns around. The function starts increasing. It's like it has a valley here. All right? So it must be a relative minimum. Okay, that's our first example. Let's try this one. This one's a little bit more complicated. So the first thing is to find the critical numbers. We want to find the points where the first derivative is 0. So y prime equals -3x squared plus 24x minus 45. I want to set that to 0. Now, that's kind of a beast of an equation. If we divide through by negative 3, because negative 3 goes into all the terms, I think it gets a little bit nicer. So if you divide by negative 3, we get x squared minus 8x plus 15 equals 0. You can use your solve on the calculator or the quadratic formula, but this factors. And we get x equals 3 and x equals 5. Those are the critical points. So let's put 3 here and put 5. Now, those are the places where the function might turn. So we got to check the intervals and see whether it's increasing or decreasing in each of the intervals. All right, I'll do that right here. So let's put in a number that's less than 3. 0 is nice. Y prime of 0 would be negative 3. So I'm substituting into the first derivative. Times 0 squared plus 24 times 0 minus 45. That ends up being negative. It's less than 0. So the first derivative is negative and the function's decreasing here. Okay, let's check a number between 3 and 5. Let's put in 4. So we have y prime at 4 equals negative 3 times 4 squared, that's 16, plus 24 times 4, and then we have minus 45. Okay, that's negative 48. That's plus 96 minus 45, which I believe is 3. All right, I know it's positive, so it's greater than 0. It equals 3, I believe. So this was going down here. The derivative was plus here, so the function's going up. Now we got to check a point in this interval here to the right of 5. So we're going to check y prime of, say, 6. And that would be negative 3 times 6 squared, which is 36, plus 24 times 6, minus 45. Okay, so that's minus 108, plus that would be 120, 144, minus 45, and if you add that up, you get a number less than 0. So the derivative is negative there. Okay, so the function is decreasing. I'll put the results over here. We're all over the place. The function is decreasing from negative infinity to 3, and from 5 to infinity. And the function is increasing from 3 to 5. Now, we have a graph over here, and we can see that what we came up with is right. If you look over here, the function is decreasing until we get to this critical point at 3. Then it does increase until we get to 5, and it decreases after that. We did it without a graph, so that's a good job. Now, we also realize that 3, right here, the function goes from decreasing to increasing. That's a relative min. And here, it goes from increasing to decreasing. It's like it reaches the top of the mountain, then it comes down. That's a relative max. All right, that's a lot of math. I believe we have just one more example here. So here's our last example. First step, find the derivative and set it equal to 0. So we have 4x cubed minus 4x equal to 0. All right, we have to solve this. We can factor out actually a 4x. So this would be 4x times x squared minus 1. And we can actually factor this. This is 4x times x plus 1 times x minus 1. So we get the critical points are x equals 0. That would make this 0. X equals negative 1 and x equals positive 1. So we graph them. Negative 1, 0, and 1. Now, the next part's a little tedious, but with a calculator it's not so bad. We got to test the intervals by using the first derivative here. So let's put in negative 2. Y prime of negative 2 would be 4 times negative 2 cubed minus 4 times negative 2. And this would be 4 times negative 8, which is negative 32, plus 8, which is negative 24. Function's decreasing here. So we can pick any point in this interval to test the derivative, use the first derivative, and it'll tell us if it's positive or negative. All right, let's put a point in here. For instance, negative 1/2. Y prime at negative 1/2 equals 4 times negative 1/2 cubed minus 4 times negative 1/2. We can use our calculator to do this. This would be 4 times negative 1/8, which is negative 1/2. This is plus 4 times 1/2 plus 2. That's greater than 0. Increasing. Okay, we got 2 more intervals to check. Let's put in 1/2. Y prime at 1/2 is 4 times 1/2 cubed minus 4 times 1/2. This is equal to 1/2, and this would be minus 2, which is less than 0. Function's decreasing there. Then our last interval at 2, let's put in 2. Y prime at 2 would be 4 times 2 cubed, which is 4 times 8, minus 4 times 2, which would be minus 8, is 24. It's positive. So it's increasing. So I'm not going to write down the intervals this time, but it's decreasing here, increasing, decreasing, increasing. It's exactly what we see here. It's kind of a W-shaped graph. It's decreasing until we get to this first critical point, increases to x equals 0, decreases to x equals 1, and increasing after that. This is a relative minimum. This one's a maximum. That one's a minimum. Min, max, min. Wow. So using the first derivative is pretty powerful. We really don't need the graph. Okay. Now, I know we covered a lot of things. We got 2 functions for you to analyze here. You can use your TI-89 to help you. So remember, the first step is to find the critical points. Take the derivative, set it equal to 0. Then draw a number line and test the first derivative. Use the first derivative to test the intervals. And list where it's increasing and where it's decreasing. Okay, good luck.